Good morning, students. Welcome back to science class on the chapter electricity. In the previous class, we have discussed some problems related to resistor series and parallel. Okay, so today also we'll discuss some problems. First, I'll write the question. Yes. See here. Hmm. In the circuit diagram, suppose the resistors R1, R2, and R3 have the values 5 ohm, 10 ohm, 30 ohm respectively, which have been connected to a battery of 12 volt. Calculate first one the current through each resistor. Current through each resistor means see here I, right? So this current I which divides into I1, I2, and I3. Okay. So once again here you get I. Then the second one, the total current in the circuit. Total current in the circuit. Then total resistance in the resistor. So here we need current through each resistor. That is I1, I2, I3. We need I1, I2, I3, and we need I also. Total current in the circuit. We need total current in the circuit and current through each resistor. Okay. Then total resistance in the circuit. Okay. Yes, a simple one. Solve the. See, find the solution for this question and put your answer in the comment box. Quick. Here already answered almost Sangeet. Total current is 4 ampere. Yes, so total resistance is 3 ohm. Okay, let's check. First one. So what is the total voltage? That is 12 volt. 12 volt. Okay. So R1 is equals to 5 ohm. R2 is equals to 10 ohm, and R3 is equals to 30 ohm. Okay. Yes, sir. We need I1, I2, I3. First calculate I1. For that we have formula V is equals to I1 into R1. We need I1, right? So V divided by R1 is equals to I1. Then we can write I1 equal to V by R1. So solution, what is V value? That is 12, and R1 is 5 ohm. R1 is 5 ohm. So 5, 12 divided by 5. What is the answer? Quick. Then second one, we need I2, right? So V is equals to I2 into R2. V by R2 is equals to I2. Right here. I1 is equals to 12 divided by 5. So I2 is equals to 12 divided by 10. Okay. Next we need with V is equals to I3 into R3. V by R3 is equals to I3. I3 is equals to V by R3. So that is V is 12, R3 is 30. Yes, fast. Raghavendra Adier 2.4 ampere. I1 is 2.4, I2 is 1.2, I3 is 0.4. Okay, so I1 is 2.4, 2.4 ampere. Okay, then I2 is equals to 12 by 10, that is 1.2. Okay, 1.2. Next, I3 is 0.4, 0.4 ampere. Okay, see, just observe here 5 ohm. Okay, 5 ohm, the current is 2.4 ohm. Then in the case current resistance is 10 ohm and the current is 1.2 ohm. Third one, 30 ohm, current is 0.4 ampere. 0.4 ampere. Okay, you know, right? Current is inversely proportional to resistance. When you increase the current, resistance decreases, or when you increase the resistance, then current decreases. So here resistance is more, right? So that's why here current is very less, 0.4 ampere. Here resistance is less, so that's why here current is more. Okay, when you increase the resistance, then current decreases, so that's why current is inversely proportional to resistance. Okay, next, so first one is alright, the current through each resistor, that is 2.4, 1.2, 0.4. Next question, find the total current in the circuit. See here, you can calculate total current in the circuit, that is by using this formula also. Okay, V is equals to I into R. Using this formula also, you can calculate total current, or using this formula, I is equals to I1 plus I2 plus I3. Okay, see, if you want to use this one, here you should know resistance value, that is total resistance in the circuit. But here you don't know, right? Here you don't know total resistance, but you know only values of the individual resistors, but you don't know the total resistance in the circuit. First, if you calculate the total resistance, then you can to calculate current, then you can go with this formula. See, already we have found values, right? I1, I2, I3. Okay, so very simple one. We can go with I equal to I1 plus I2 plus I3. But if you use this one, you will get the same answer. So now calculate second one, the total current in the circuit. So formula I is equals to I1 plus I2 plus I3. Okay, so I1 is 2.4 and I2 is 1.2, I3 is 0.4. Okay, so total current 3.6 and 4.04 ampere. Okay, so total current in the circuit, that is 4. See here, it flows 4 ampere. If you connect ammeter here, you will get 4 ampere. If you connect here, you will get 4 ampere. If you connect this ammeter here, you will get 4 ampere. Here also 4 ampere. Here also 4 ampere. But if you connect this ammeter here, then you won't get 4 ampere. If you connect here or here, you will get 2.4. If you connect this ammeter here or here, you will get 1.2. If you connect this ammeter here or here, at that time you will get 0.4. This 4 ampere current, this 4 ampere current here, which divides into 2.4 here and 1.2 here and 0.4 here. Okay, so here the division is not equal. Why? Because the resistors values are different. Okay, so next one, the total circuit resistance. Total circuit resistance. Total circuit resistance. Here also, see here, you can calculate using this formula. V is equals to I into R, because already you know, right, voltage, that is 12 volt, and you know, see now you calculated that total current, that is 4 ampere. You can use this one, or you can use this one, total resistance. Now see here, all the resistors in a parallel, right? When the resistors in parallel, then we use to calculate total resistance circuit, we use 1 by R equal to 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So what is R1 value? That is 5 plus R2 is 10 plus R3 is 30. Okay. What is the LCM of 5, 10, 30? Yes. Find the LCM and tell me what is the resistance of the circuit. So LCM is 31 by R. Okay. If you don't know how to take LCM, see here 5, 10, 30. First 5 ones are 5 twos are 5 6 are. Next take 2. 1 2 ones are 2 threes are. Next 3 1 comma 1 then 1. So 5 into 10 10 into 3 that is 30. So 1 by R 1 by R is equals to 30 is the LCM. Okay. Next here you have to multiply into 6 here and here into 3 and here into 1. It is 6 plus 3 plus 1. Okay. We need R, right? So take the reciprocal. So R is equals to 30 by 6 plus 3, 9 plus 1, that is 10. Cancel. So finally we got R is equals to 3 ohm. Okay. See here you can redraw this circuit as 5 ohm, 10 ohm, 30 ohm, right? You can redraw like this. That is R is equals to 3 ohm. Instead of using 3 resistors, 5, 5, 10 and 30, 5, 10 and 30. Using these resistors in the series, you can use one resistor like this. Okay. Next, see here, now we can calculate R when using this formula V equal to I into R. At that time also you will get the same answer. Okay. See here. So here we are used that is 1 by R equal to 1 by R plus that formula, right? So now we can use this one. What is V? We need R, right? So V by I equal to R or R equal to V by I. So what is V value? That is 12. Current is 4. 4 ones are 4, then 3 ohm. See here we are used Ohm's law equation. Here we have used this 1 by R equal to R1 plus R2. Here also we got 3 ohm. Here also we got 3 ohm. Okay. Yes. Next one. Yes. See here, if in figure R1 equal to 10 ohm, R2 is equals to 40 ohm, R3 is equals to 30 ohm, R4 is equals to 20 ohm, and R5 is equals to 60 ohm, and a 12-volt battery, and a 12-volt battery, load battery is connected to the arrangement. Calculate the total resistance in the circuit. Calculate total resistance in the circuit and the total current flowing in the circuit. So here we need R and I. For that, we know formula V is equals to I into R. Here we know the value of V, but we don't know I and R, right? Our work is to calculate I and R. See, first, just observe here. Now, see, these two are in parallel. These three are in parallel. But what about this combination and this combination? Okay, when you solve these two, it will become one. See here, when you solve these two, then it will become one, right? It will become one. Okay, then now here also these three are also in parallel. If you solve this one, then these three will become one. Okay, like this. So here you can redraw the circuit. You can redraw the circuit as like this. Okay. Now observe here. Now these two are in a series or parallel. Okay. See, already you know, right? Series means what? End-to-end connection. Okay. There is no mixture of any other ends. Here just two ends are connected here. One end, this one, and this end here. So now here these two are in series. Okay, these two are in series, which means this combination and this combination both are in series. But these two resistors are in parallel. These three resistors are in parallel. But this combination and this combination both are in series. Okay, so first solve these two resistors, then solve these two resistors. Okay, so then you will get this kind of circuit. At last solve these two. Okay, yes. Now see here, these two are in parallel, right? So I will use this here. The formula is 1 by R dash. Okay, 1 by R dash. Like R dash means just taking the power like this. Okay, so 1 by R dash, that is 1 by R1 plus 1 by R2. Clear? Next, to calculate total resistance here, among these three resistors, here I will take R double dash. 1 by R double dash, that is 1 by R3 plus 1 by R2 plus 1 by, sorry, R4, R4, 1 by R5. Okay? Yes, first find the answer here. Calculate R dash, first one. So what is the answer? So already here some students you answered total resistance is 30 ohm. No. At Vaishnavi. So total resistance is 18 ohm, correct? Next, Sridhar Jain, total resistance is 10 ohm and the total current is 0.67 ohm. It's wrong. Total resistance is not 10 ohm. Okay. So Nandini power R1 R dash is 8 ohm, correct? 8 ohm. Yes, correct. So R double dash is R2, that is 10 ohm. Okay, correct. So here first one, this one is 1 by 10 plus 1 by 40. So 1 by R dash equal to 1 by 10 plus 1 by 40. So LCM is 40, right? Here 4 plus 1. Here you have to multiply 4 and here 1. So 1 by r dash. So that is 5 by 40. We need r dash, right? So r dash equal to 40 by 5. That is 8 ohm. We got 8 ohm right here. So r dash is 8 ohm. So now calculate r double dash. That is 1 by r double dash is equals to 1 by r3 plus 1 by r4 plus 1 by r5. Okay. So what is r3 value? 1 divided by 30 plus 1 divided by 20 plus 1 divided by 60. Okay. Yes, take the LCM and find the answer. So LCM is 16. 1 by r double dash is equals to LCM is 60. Here you have to multiply 2, here 3 and here 1. So 2 plus 3 plus 1, that is 6 by 60. Okay. So we need r double dash, that is 60 by 6 is equals to 10 ohm. R double dash is 10 ohm. Okay. So we got this combination as this combination is 8 ohm and this combination is 10 ohm. When you resolve this circuit, then both will become both are in a series, right? So now it will become 1. So this is R dash, that is 8 ohm. R double dash, that is 10 ohm. So now these two are in series. Now these two are in series. Yes. What is the formula to calculate total resistance when the resistors are in series? That is R is equals to R1 plus R2 plus R3. Okay. The resistors are in series. We have formula R is equals to R1 plus R2 plus R3, right? So here R dash plus R double dash. R dash is 8 ohm, R double dash is 10 ohm. So total R is equals to 18 ohm. So total resistance in the circuit, that is 18 ohm. Next, calculate the total current flowing in the circuit. So total current flowing in the circuit. Yes, for see already we got R value and we know V value, right? So directly we can use V is equals to I into R. Okay, I into R. So we need I, right? V by R equal to I, or I equal to V by R. That is 12 divided by 18 ohm. So just divide 12 divided by 18 ohm. So you will get 0.67 ampere. Okay, 0.67 ampere. Here See now calculate current through this resistor and this resistor. Current through, see this is a homework for you. See here. Now calculate I1, I2 and here also I3 current through here. I3, I4 and I5. Okay. See here. Voltage here and here same. Okay, voltage here and here same. But remember, keep in your mind, these two are in series, these two are in parallel, and these three are in parallel. But this combination in series. So here you can't take 12 volt, 12 volt, 12 volt, 12 volt, 12 volt here. Okay, why? Because here voltage which divides right by among this combination and this combination. Why? Because this combination are in series. Okay, so that's why. So think and do it. Find out I1, I2, I3, I4, I5. Okay, so this is a homework for you. So I will stop here. Tomorrow I will continue the class. Problem discuss